All right, hello everyone. Welcome to the review video for the Chapter 1 study guide. I'm just going to be going through all the questions, probably going at a somewhat quick pace to keep the video short, but it's a lot easier for you to just like pause the video, take it step by step. And then also if you're watching this beforehand, just a reminder that I'm going to be having the review session from 8 to 9 on Tuesday, where we'll be going through these questions together. So you can either watch the video, come to the review session, or do both. I definitely recommend going through these questions. These are a lot that you may see on the test tomorrow. Maybe just switched up the numbers. But all right, let's get started. So for the number one, we have solve the linear equation, negative 4x minus 4 minus 6 times x plus 1 equals 7x minus 6. So the first thing I'm going to do is distribute the negative 6x. Negative 4x minus 4 minus 6x minus 6 is equal to 7x minus 6. Now what I'm going to do here is I'm going to combine my like terms on the left side. So my 4x and my 6x, my negative 4 and my negative 6. So I get negative 10x minus 10 is equal to 7x minus 6. I'm going to add 10x to both sides. Add 6. So I end up getting negative 4 is equal to 17x divided by 17. I'm getting x is equal to negative 4 over 17. And that is really it for number one. When we get to number two, so that's where we get to fractions. No one likes fractions. So your goal always is to get rid of the fractions right away. In this case, I know that y squared is equal to y plus 5, y minus 5. So that means my least common denominator for these three fractions would be this right here, x plus 5 times, or not x, y plus 5 times y minus 5. So that's what I'm going to multiply each one of these fractions by. So in this case, the y plus 5s would get canceled, so I'd be just left with, I can write it out. So 3 So this first one, my y plus 5 would get canceled when I multiply it, so I'd just be left with y minus 5 getting multiplied with the top. For this middle one, the y minus 5 gets canceled, so I just be left with a y plus 5 being multiplied with the top. And this one both get canceled, so I'm just left with my 6. So kind of distributing this as I rewrite this, I get 3y minus 15 minus 5y minus 25 is equal to 6. Combining like terms on this side, I get negative 2y minus 40 is equal to 6. Plus 40 plus 40. Move my work up here, I get negative 2y is equal to 46. Divided by negative 2, divided by negative 2, I end up with y is equal to negative 23. So it's always hard with fractions, always figuring out what you have to multiply each one by to get rid of them. One rule of thumb I usually always go by is like when in doubt, just multiply them all together. So you could multiply this by like y plus 5, y minus 5, y squared minus 25. You would have a lot left over, but at least you know you got rid of your fractions. All right, the next one, number 3, it's just asking us to solve for h. So with this one here, I'll rewrite it because I have enough room. So my first thing I'm going to do is to get rid of this 1/2. I'm going to multiply both sides by 2. So I get 2a is equal to bh. And the last thing I have to do is divide by b. So I end up getting h is equal to 2a over b. You might have a little bit more complicated one. On the test, maybe it might have like a square or a square root. But that's basically the concept. You're just going to be moving around the letters and maybe the other numbers to solve for one specific variable. Ooh. All right. Number 4. So this is a word problem. It says you inherit $10,000 with stipulation that for the first year, the money will be invested in 2 stocks, paying 6% and 11%. How much should be invested at each rate if the total interest earned for the year is to be $900? So these questions are always going to be the same. You'll set them up the same way. So if I have $10,000, if I'm splitting them up into 2 different stocks, in one stock, I'm putting X amount of dollars. So that leaves for my second stock, 10,000 minus X dollars. For my interest rates, just remember 6% turns to 0.06. 11% turns to 0.11. So my equation for this, I'm breaking it up, will be 900 is equal to 0.6x plus 0.11 times 10,000 minus x. So then now I'm going to solve for x. So I'll distribute my 0.11 over there. So 0.11 times 10,000 is 1,100. And then minus 0.11x. I'm going to minus my 1,100 over, and then also combine my x's. So I get negative 200 is equal to negative 0.05 x. And then, sorry, I just realized this. I was treating it as a 0.06, but I wrote it as 0.6. Just remember the zeros here. So then I divide by 0.05. Pen's dying on me. 5x. So that leaves me with x is equal to 4,000. So then now I have to look back with what this x represents. So since I did 0.06 times x, that means that this x value represents how much I was putting in at the 6% stock. So then to find out how much I put at the 11%, I'll just do 10,000 minus x. Or in this case, 10,000 minus 4,000. which gets me 6,000. So the way you would write this is 4,000 at 6%, 6,000 at 11%. And that is it for number 4. All right. With number 5, we're just working with complex number I. They're just asking us to simplify this, put it in standard form. Remember that standard form is A plus BI. So even if you have like a fraction at the end, you want to split it up and leave it as a specific fraction as A plus a distinct fraction of B times I. And this one I just have to distribute some negative signs to get started. So I end up with -1 plus 2 plus 4i minus 5 minus 2i. So I'm combining my like terms. -1 plus 2 minus 5 gives me a -4. And then 4i minus 2i gets me a positive 2i. And that's my answer. -4 plus 2i. Rewrite that 4, make it a little better. For number 6, this is where we have to think about the complex conjugate to get rid of the I on the bottom. So what I'm going to do is I'm going to multiply. I'll just write what I'm multiplying it by. It's going to be 8 plus 6i. On both the top and the bottom. So in that case, we get something like 6 plus 7i times 8 plus 6i over 8 minus 6i times 8 plus 6i. So now I'm going to FOIL on both the top and bottom. All right, so the top of my fraction, we have 48 plus 36i plus 56i, and then plus 42i squared. That's going to be all over 64 plus 48i minus 48i minus 36i squared. So my 48i's cancel. That should happen every time on your bottom. If that doesn't, check your work. You might have messed something up. And then remember that I squared is equal to -1. So I'm going to replace this with a -1, place this with a -1. And if I combine my 36i and my 56i on the top, I get 48 plus 92i minus 42 all over 64 plus 36. Adding like terms on the top and bottom, I get 6 plus 92i over 100. So simplifying, 6 over 100 plus 92i over 100. And that simplifies to 3 over 50 plus 23 over 25i. All right. For number 7, it's asking us to factor the trinomial using the AC grouping method. So what that means is I'm going to multiply A, which is 10 in this case, by -6, which is my C. So then I'm going to do, all right, so that's -60. What multiplies to 60? That adds to 11. Well, one thing that comes to mind is 15 times 4. So then for it to be 11, I'd have to have a positive 15 and a negative 4. 15 minus 4 is equal to 11. So I get 10x squared plus 15x minus 4x minus 6. On the left side, they both have a 5x in common, so I'm left with 2x plus 3. This side, I pull out a -2, and once again, I'm left with 2x plus 3. So that leaves me with the factored form 5x minus 2 times 2x plus 3. And in this case, that's all they're looking for. It's not equal to 0, so we don't have to solve for x. For number 8, it's asking me to use the square root property. So my first thing I'll do is divide by 3 on both sides. So I get x plus 2 squared is equal to, that gives me 28. Taking the square root of both sides, I get x plus 2 is equal to the square root of 28. This is where I'm going to simplify it on the left, or I guess on the right. So 28, that's divisible by 4 and 7, 4 times 7. And then 4 is 2 times 2. So there's my double prime. So that's going to go on the outside of the square root, and on the inside, I'll be left with 7. So x plus 2 is equal to 2 square root of 7. One thing I forgot to add, super important, whenever you take the square root, remember your plus or minus. This is plus or minus the square root of 28, plus or minus the square root of 28, plus or minus 2 square root of 7. So now I'll minus by 2 to get x alone. So my final answer, writing it over here, I get x is equal to -2 plus or minus 2 square root of 7. All right, completing the square. So for this one, your first step every time whenever it says completing the square is moving over the constant. So I'm going to minus both sides by 25. So I have x squared plus 6x. I always leave this space here to write down what number I'm going to add, equals -25 plus, I shouldn't put plus yet because we don't know if it's positive or negative. Just leave my blank. So then I do the b over 2 squared. So that my b in this case is 6. So 6 divided by 2 squared is equal to 3 squared is equal to 9. So I'm going to add 9 on both sides. So x squared plus 6x plus 9. The reason we added that 9 is to put in the perfect form. So it's x plus or minus some number squared. In this case, you always go with what is b divided by 2. Also remember if it's positive or negative. In this case, it was a positive 6 divided by 2, so I got a positive 3. So my simplified form will be x plus 3 squared. And that's equal to a -16. Square root of both sides, to get rid of the squared, we get x plus 3 is equal to the square root of -16. Remember your plus or minus. So I'm going to minus 3, minus 3. So I get x is equal to -3. And then my -16, well, that's actually the square root of 4. But since it's negative, it will be 4i. So I get -3 plus or minus for I. All right, number 10 is asking me to compute the discriminant. So remember that the discriminant is, what am I writing on? It is b squared minus 4ac. So my b is 7, so 7 squared minus 4 times 1 for a times 6 for c. So I get 49 minus 24, which is equal to 25. Well, what do these numbers represent? If I get a number greater than 0, it's 2 real solutions. If I get a number equal to 0, it's 1 real. And less than 0 is 2 imaginary. Ooh. If I get one less than 0, it's 2 imaginary. So in this case, we got a number greater than 0, so this one will have 2 real solutions. Number 11 is just asking us to solve using the quadratic formula. Remember, that is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, filling everything in, I get a negative 12 plus or minus the square root of 12 squared minus 4 times 3 times 7 all over 2 times 3. Well, in this case, for some reason, I'm writing 3 times 2. Simplifying some of the multiplication, I get negative 12 plus or minus. 12 squared is 144. 4 times 3 times 7 is a 84. That's going to be all over 6. Inside the square root, 144 minus 84 ends up being 60 all over 6. So simplifying the square root of 60 on the right here, I know it's divisible by 4 and 15. So 4 is 2 times 2, and 15 is 3 times 5. So my 2's go on the outside, or not my 2's, my 2. Since I have just a 1, 3, and 1, 5 left, inside the square root is 3 times 5 left. So in that case, I get negative 12 plus or minus 2 square root of 15 all over 6. And then this is where I can simplify stuff. Everything's divisible by 2, so that's what I'll do. So my final answer for this is negative 6 plus or minus the square root of 15 all over 3. All right. Next one is solve the polynomial equation by factoring. What I'm going to be doing first is moving everything over to the left side. So I'll be minusing by 45x and 27. And so I get 5x cubed plus 3x squared minus 45x minus 27. Then I'm just going to pull out, kind of like breaking it up down the middle. What's common on the left, what's common on the right. So on the left, I can pull out an x squared. That leaves me with 5x plus 3. If I pull out a negative 9 on this right side, that also leaves me with 5x plus 3. So I can now rewrite this as x squared minus 9 times 5x plus 3. And then there's one more Step of factoring, I can take this x squared minus 9. That's a difference of perfect squares. So that simplifies to x plus 3, x minus 3. And then we still have that 5x plus 3. So equaling them all to 0, x plus 3 equals 0, x minus 3 equals 0, and also 5x plus 3 equals 0. I end up getting x is equal to -3, 3, and -3 over 5. All right, next one is solve the radical equation. So for these, you want to get the square root alone. So move everything over to the right, then square your square root and solve for x. So I'll add my 8 over first. The square root of 30x plus 15 is equal to x plus 8. Now I have to square both sides to get rid of this square root. So I get 30x plus 15 is equal to, so now this is an x plus 8 squared. I'm going to write it as x plus 8 times x plus 8. So I'm going to FOIL it right now. So foiling, the left side stays the same, 30x plus 15. Over here, I get x squared plus 8x, which is plus 16x plus 64. Then moving all this over, I'm going to minus 30x minus 15. Minus 30x minus 15. I end up getting 0 is equal to x squared minus 14x plus 49. So you could do it over to the side. What multiplies to 49 that adds to -14? I know that it's -7 and -7. So I can show that up here. 49. -7 times -7 equals -14. There you go. So that 0 equals x squared minus 7x plus 49. This ends up simplifying to 0 equals x minus 7, x minus 7. So in that case, I just have 1 to solve for. X minus 7 is equal to 0. So therefore, x is equal to 7. But just be aware, whenever you solve one kind of in this method, when it's a square root on one side and you square it, you always have to test your answers to see if they work. So in this case, 30 times 7 plus 15 minus 8 is equal to 7. So 30 times 7 is 210 plus 15 minus 8 equals 7. 225 minus 8 equals 7. So the square root of 225 ends up being 15. 15 minus 8 equals 7. So 7 equals 7. That is true. So x equals 7 is one of my answers. All right, next one is a fraction as an exponent. Just a brief explanation of how fractions work as exponents. The top is always your power and the bottom is always your root. So in this case, I could read this as the square root of x plus 2 cubed, or the square root of x plus 2 cubed. They sound the same because they are the same, but it doesn't matter which way you write it or which one you decide to cancel out first. So if we have a root, we square it. If we have a power, we do a root by that power. So in this case, we have I'll write it as the square root of x plus 2 cubed, or cubed, is equal to 343. So in this case, the first thing I'm going to do is take the cube root of both sides. So I get the square root of x plus 2 is equal to, the cube root of 343 is 7. So I'm going to square both sides. So we get x plus 2 is equal to 49. Minus 2, x is equal to 47. And that's really it for that one. All right, number 15, solve by making an appropriate substitution. You always make u whatever this middle one is. So u is equal to x squared. U squared is equal to x to the fourth. So we get u squared minus 31u minus 180 equals 0. All right, so now we have to find something that multiplies to negative 180 that adds to negative 31. I'm not going to lie, this took me a while to try to figure out. I ended up testing almost every number. I still forget what I used, so let me look at my notes. So you end up finding that negative 36 and positive 5 multiplied together gets negative 180, add together gets negative 31. So we have u squared minus 36x, or minus 36u plus 5u minus 180 equals 0. Pulling out a u on the left side, u minus 36 plus 5, u minus 36. So we end up getting u plus 5 times u minus 36, which is equal to 0. So in that case, u is equal to negative 5, and u is equal to 36. That is not our answer. Remember, we have to plug in our x squared here. So x squared equals negative 5, and x squared equals 36. Taking the square root of both sides for both of them. I'm going to continue my work over here. I am getting x is equal to plus or minus the square root of negative 5, which ends up being plus or minus I root 5. And then x equals the square root of 36, which is x is equal to plus or minus 6. So there's our 4 answers. Plus or minus I square root of 5 and plus or minus 6. All right, number 16, very similar. We just have a different substitution. Whenever you have a negative power, so in this case, x to the negative 1, that's the same as 1 over x. So same with x minus 2 is equal to 1 over x squared. So that's how I'm going to substitute them. We'll just make it easier when I'm solving for x later. So I'll say u is equal to 1 over x. U squared is equal to 1 over x squared. So u squared minus u minus 30. Something that multiplies to negative 30 that adds to negative 1. That's going to be negative 6 and 5. So I get u squared minus 6u plus 5u minus 30 is equal to 0. Pulling out a u on the left, I get u minus 6. Pulling out a 5, I also get u minus 6. So u plus 5 times u minus 6 is equal to 0. That tells me that u is equal to negative 5 and u is equal to 6. Now subbing back in what u represents, I get 1 over x is equal to negative 5. So kind of multiplying my x over, I get 1 equals negative 5x. So in that case, x is equal to negative 1/5. Same with my 6. Multiply my x over, 1 equals 6x. X is equal to 1 over 6. So those are my two solutions. X equals negative 1/5 and x equals 1/6. All right, number 17, solve the absolute value equation. Kind of similar to how we were doing the square root before. You want to get the absolute value alone before you start dealing with it. So I'm going to minus this 4 over. So I have the absolute value of 5x plus 3 is equal to 7. When you get rid of the absolute value symbols, you write one as your normal equation. So 5x plus 3 is equal to 7. But then also 5x plus 3 is equal to negative 7. Now I just solve for x. Minus 3, minus 3, minus 3, minus 3. I get 5x is equal to 4. And also 5x is equal to negative 10. Dividing everything by 5. I get x is equal to 4 over 5 and also negative 2. All right, 18, it says solve the linear inequality and graph the solution set. So I'll just distribute this, or actually, an easier way to do this, you could either distribute the -3 and then solving for x, but I actually see that on the left side, I have two things that are also divisible by 3. So to make my life a little bit easier, making all my numbers smaller, I'm going to actually divide everything by -3. If you don't see that, that's perfectly fine. You can distribute the -3 and just go by solving x. So this actually leaves me with 4x minus 4. I divided by a negative number, so I have to flip my sign, so it turns to a greater than or equal to, and I get 3x minus 2. And this is something I can easily solve for x. So I'm going to minus my 3x plus my 4. So right there, I end up getting x is greater than or equal to 2. So that is my answer for my number line. Let's say this is 2. It's a solid dot, and it's increasing towards infinity. And then also, if you were to write this in interval notation, it's a bracket 2, because it's 2 with a greater than or equal to sign, and then comma infinity, which is what it goes to, and then always a parentheses with an infinity symbol. All right, number 19, almost done. This one is a compound inequality. You can still solve it the same way by just kind of whatever you do to the middle, do to both sides. So I'm going to multiply everything by 2 to get rid of that. Actually, sorry, scratch that. I'm going to minus by 8. So minus everything by 8. So I get 3 is less than or equal to 3 over 2x is less than 15. Now I'm going to multiply everything by 2. So I get 6. Sorry, these look like squares. 6 is less than or equal to 3x is less than or equal to 30. And then I divide by 3. So this does not have a line on the bottom of it. So this gives me 2 is less than or equal to x is less than 10. So that's my compound inequality solution. It's going to be a solid circle at 2 and an open circle at 10, and then just draw the line between them. In interval notation, you'd read this from left to right. So it's a bracket 2 because it has that less than and equal to sign, comma 10 parentheses, because the 10 is only a less than symbol. So that is my interval notation. And the last one, we have an inequality with an absolute value. So my first step to get rid of the absolute value is, so when I take away the absolute value, write 1 as my normal, and then write it again, but with a flipped sign, and negate the right side. So it turns from a less than 7 to a greater than -7. And now I just solve. So multiply both sides by 2. I get 7y plus 14 is less than 14. And then also 7y plus 14 is greater than -14. Minus 14. I get 7y is less than 0. And also 7y is greater than -24. Divide by 7. Y is less than 0. And also y is greater than -8. So you can actually write this as a compound inequality. You can say -8 is less than y is less than 0. That could be your solution for this. I go from -8, which is an open circle, to 0. Drawing the line between. So my interval notation, reading it from left to right again, parentheses -8, comma 0, parentheses. And all right, that is it for the test review. Look for the SI Canvas page. There should be a few examples from every chapter, 1.2 through 1.7, if you want a few extra practice problems. Then also we'll be going through the test review questions or possibly any of the questions from the chapters that I posted in the test review or in our SI session Tuesday from 8 to 9 p.m. So good luck on your test. Get to studying. Don't let the first test make you realize, oh, I got to get to studying. So definitely take this first one seriously and do well on it. See you in class on Wednesday.